Here we are looking at a very common problem in analytic geometry. In this type of problems, we are given some points of a geometric shape, and some points of the geometric shape are missing. And our job is to figure out the coordinates of the missing point. Now, this type of problems can easily be solved with your knowledge of vectors. So let's have a look at it. In part A, well, here we are given 3 points, A, B, and C, and we need to find a fourth point so that A, B, C, and the fourth point T form a parallelogram. Now, let's first sketch this here accurately, actually in our coordinate system. We have our coordinate system given here, and our point A at -2, 2, B at 2, 3, and C here at 3, -1. So when we look at this, let's try to see where we could add a fourth point so that this becomes a parallelogram. Now we can see here, if we would add a point D here, well, here we would get this parallelogram that I'm drawing here. Okay, this would be a first parallelogram. Now, it's not so nicely drawn, but you can see that it is a parallelogram. Now, there's actually a second possibility how to create a parallelogram. You could also add a point up here. So if we would add a point, let's do this in green, up here, then this could also be a parallelogram. You just have to look at it in this way. Now we have this green parallelogram. So let's call this D2 and this over here D1. D1 has coordinates 1, 2, 3, 4, 5, 6, 7, 7 and 0. And D2 has the coordinates -3, -3, and 1, 2, 3, 4, 5, 6. Okay, now we have two parallelograms already, and actually we see that there's a third option if we put our point down here. So let's do this in blue. So if we add the point, another point here, and we call this D3, then here we have another parallelogram, which is this one here. So actually there are 3 points here. The last one has coordinates now -1 and -2. And for each of these points, we can form a parallelogram. Now, in this case, we did this graphically, but as we will see in a moment, and that's actually part 2, part B here, you can solve this problem purely arithmetically or mathematically. And for this, well, you don't need a coordinate system. All you need is a little sketch. So here, we don't do an accurate sketch or something like this. We just have our origin and our points A, B, and C, just as before. And as I said, we don't need the coordinate system. That's enough here. We just need the sketch, and we have these 3 possibilities how we could place these points. So D1 over here, D2 up here, right? And then D3 down here. Now let's see how we can use our knowledge about vectors to actually figure out these points here. So as we can see here, we need to find a way how to describe this vector here. So the position vector OD1, right? That's this one here. And well, if you look at this problem, then you can see that this position vector OD1 could be described by chaining 2 vectors, namely this one, OC, plus this vector here. right? But this vector here, well, this we will actually have, it's just the vector AB. So the vector OD1 is equal to OC, so this vector here, plus the vector AB. That's this one here. Now that's one possibility. You could also look at it differently. You could also say, well, it's this one here. Let's first go here, and then we go over here. Now, how would you describe this vector chain here? So this blue vector chain is simply, again, we have OD1 is equal to the first one, which is OB, plus the second one, which is, well, it goes from B to D1, but that's the same vector as AC. So that's just the vector AC, right? So that's also a way how we could describe AD1. Now, well, we have just to figure out these vectors here, but this we can do. So let's quickly do this. So this would be OC. Up here we have the points given again, so the coordinates of the points. OC would just be 3 minus 1 plus AB. Now AB, that's just endpoint minus starting point, so that would be 2 minus minus 2, so 4. And here 3 minus 2, 1. And if we add that up, we get 7, 0, which is actually the solution we got over here when we did this graphically. So this is correct, right? And you would get the same if you calculate that. You would also get the vector 7, 0 here. Now for the other ones, let's also quickly do the other ones. Here in this case, we are looking at, you want to know this position vector here. And one way would be to add OA plus this vector here. So that would be OD, let's do it up here, OD2 is equal to the first one, OA, plus this one, and that's the same vector as CB, which we can figure out using our coordinates here. So we are not going to do this. You can actually do this on your own as a little exercise. There's also a second way how you could look at this. You could first go up here, right? And then go over here. Again, also this, we have, this would just be OB plus CA. And for the last one here, again, we want to figure out this vector here. Now, one possibility would be to just go here first. So that would be the vector OC, and then over here. So let's keep the purple color. OD3 would be equal to OC plus BA. And again, there are other ways how to get here. So we could also go up to A, so OA, and then plus BC. That would also be a possibility. Right? So we saw that we can solve this problem purely mathematically. And since we can do this purely mathematically, we could also do this in 3D. So that's actually part C here. So in C, we are given the points A, B, and C, and we should determine all the points D so that we get a parallelogram. Now again, first thing we do is let's create a little sketch. So we have our origin, we have our points A, B, and C. Doesn't really matter where they lie. We just need to have this as a sketch so we can figure out our paths, basically, our vector chains. So there are 3 options now, right? How we could place this third point. One would be here, D1. So here we get this parallelogram here. Not so nicely drawn now. There's a second one up here, where we would get this parallelogram here. That looks almost like a square, so this would be D2. And we can also place one down here, more or less. So we get this parallelogram here. Okay. It's really not so nicely drawn, but you get the idea. Now, that's enough now to figure out what you actually have to do. So for D1, if you want to get D1, so we are looking at the vector, position vector of D1, so OD1, and we need to figure out how to get here. One way would be to go, let me show it like this. So go to, let's say we go to B first, so OB plus CA. So we want to go up here and then down here. So that would be equal to OB plus CA, and we will get the coordinates of the point D1. Well, let's actually quickly do this in this case. So OB is just the position vector of B, so it's 1, 2, 3 plus CA. So from C to A, here it's from -2 to 4, so that's 6. From 0 to 2, it's 2, and from 4 to -1, that's -5, or you just use the endpoint minus starting point formula to get that. And if we calculate that, we get 7, 4, -2. So in the end, our point D1 has coordinates 7, 4, -2. Always assuming that we did everything correctly here. You could do the same thing for the other points. So for, let's do the second one as well, OD2. How do we get here? So there are different paths again. One way would be to go to B again, so OB, but now instead of going down here, we go up. So we could still use this vector CA, but now we subtract it, so minus CA. And then you would get the position vector of OD2, or the position vector OD2. And you can do this for the third one, D3, just the same way. And yeah, that's generally how you solve these types of problems. So it's always best to create a sketch where you see what you need to do. So create a sketch first, then figure out how you have to lay the points, and then figure out how you get to this point by connecting vectors that you know.